Okay, good day class. Welcome back sa ato ang discussion. Padayon ta on the topic electric fields in matter. So in the previous discussion that we had, especially sa previous na video, we consider the effect of the external electric field on, let's say, individual atom. Di ba? Nag-example ta atong atom, a hydrogen atom, both the primitive and a more realistic na model. Nag-expose mo siya into an subjected via an electric field. So we know nga naa siya effect. Ang effect sa electric field on the atom is stretch niya. The electron cloud is attracted towards the electric field. Okay, and then the nucleus is pushed away, right? Nag-ana sila. So say this is the direction of the electric field. This is the direction of the electron cloud, and this is the direction po sa nucleus. It's like nagtug of war sila, but in the end, balance sa gyapon ng ilang force, okay? Such a way na stretch lang siya gamay ang imong atom, uh, leaving your atom polarized in that sense. Polarized siya kay na-stretch siya and in the direction siya sa electric field. And that's why ang imong atom na siya dipole moment. So na siya uh, opposite charge of negative and positive. Ang direction niya is let's say a direction is always towards the positive, and that is towards the direction sa imuhang electric field. We also consider the effect of electric field on a molecule, the same on a CO2 nga atom, carbon dioxide, and even we had an example on a water molecule, right? So I have a water molecule and then exposed to an electric field and they close. So right now we are in the position to answer qualitatively our original question before, that is, what happens to a piece of material, specifically the electric material, when it is placed in an electric field? So ma-expose ang imong dielectric field ay imong dielectric in an electric field. Okay? Going back ani. So although the electric is an insulator, but the electric field has an effect on it because the dielectric has atoms on it. Nasa mga molecules, and then those molecules and atoms will definitely react with the electric field. Okay? So it's either duha man ka mechanisms, right, na ma-affected ang mga molecules or atoms sa electric field. It can either be stretched and rotate. Okay? The one that we had on the previous video was on water molecule, wherein ang water molecule is a polar molecule man na siya. So polar molecule, it has a permanent dipole. Na siya built-in nga dipole because na siya positive daan and negative charge na in opposite direction, right? The negative is towards the oxygen molecule, and the positively charged, partially positive, is towards the hydrogen atom. Okay? So that's the case. So ang imong water molecule will experience a torque. It will tend to line up along the direction of the electric field until such time na maka-attain siya balance or mo equilibrium siya, and that's why mo stop na siya turn. So ang iyahan ng polarization is pointing towards the direction of the electric field. So if we look back sa kani, right, you have your electric field. So kani siya is electric field na siya force nga exert dinhi sa positive, at sa negative is dara pod. So as a whole, your molecule will rotate. Okay, it will experience a torque because of the presence of the electric field. And actually, naapa na siya stretching gihapon, mas stretch gihapon ang imong molecule, although wala lang siya nato siya i-consider, only the turning nato i-consider because it's easier for for us, or it's easier for the electric field to rotate the molecule than to stretch it. So actually ang mo-dominate gid nga term is ang katong ang mo-dominate nga mechanism is ang katong pag-turn sa imuhang molecule instead sa katong stretch niya. Okay? So it's a lot easier to rotate a molecule than to stretch it. So um, in this discussion, we'll have we'll define a new quantity. So we have this one. It's actually related sa dipole moment, but this time it's a capital P. So it's a dipole moment per volume. So in ano siya, this is capital P, then related to the small p over volume. So that's your dipole moment. Why we do this? Nganong mo shift ta from dipole to dipole to what do you call this? To a big P nga notation because we are considering now a material. So a material has not only di lang kay usa ang iyang dipole moment, daghan kay siya kay it is composed of let's say millions or even billions of atoms and molecules. So it's more natural or what do you say? How would I say? It's more convenient for us to refer to this one. It's just like a density. Okay, so dipole moment per volume. Okay na tong sa molecule and atom kay usa naman to siya, right? So we can talk about this small p. But since we are considering now a material, a dielectric material specifically, so we'll have to deal with this big P. Okay, that's the dipole moment per unit volume. So as I've said kanina, the electric field is able to rotate and to stretch the molecule sa depending on the iyang mechanism kung asa ang mas mo dominate. Okay? But most probably, iha yung i-trigrotate. Okay? And napoy stretching gamay. It's even possible for some materials to freeze. Iyang i-freeze niya ang polarization. And ang iyang polarization kay mo persist even though the field is removed. Because naturally, if na electric field, diha naman ang naay polarization. Alright? But if you take away the electric field, most of the material, wala po ang iyang polarization. But there are other materials wherein mo persist ang iyang polarization, meaning mo retain ang iyang polarization orientation even though the electric field has been removed. So for this as discussion, we'll try to find out the question, what is the electric field of the material, okay, of the dielectric. For now, we'll ignore the external field that causes the polarization. We'll ignore some other factors na naa sa imuhang material, let's say na yung mga free electrons dira or unsa ba, we'll just ignore that one. We'll just have to focus on finding the electric field of the material due to the dipole, okay? Due to the dipole moment, due to this big P, okay? Tungod lang gid ana, wala na ato sang i-simplify and then later on we'll come back to it and then we'll add them together including all those free electrons and those or other excess nga mga factors nga maka-add up sa mga electric field. But for now, we'll consider on finding the electric field due to the polarization itself. Okay? So let me go back here. Okay. So this time we'll try to generalize the calculation of the potential first because that will be very important and it's easy for us to calculate the electric field if we start with the potential. So instead of the dipole moment nga formula katong discrete, we'll try to generalize it on a material man siya. So we'll consider a volume distribution. Okay, it's like a dipole moment distribution siya. So recall that for a single dipole, Okay, for a single dipole, we have this, right? This one. So that's for a single dipole. But if we have a some sort of a uh, say na ako'y charge distribution of this shape, say na ako na nga charge distribution of a certain volume, so na siya dipole moment diha at that direction. So manihang dipole moment. Then we'll try to calculate the potential at this point, right? So what would be the potential at that point? Okay, okay. So we'll try to calculate the potential at that point. So this is distance r. Okay. So r is the vector from the dipole to the point at which we are evaluating the potential. Okay. So in this context, we will define this. When naaman to'y we declare this one formula at the beginning sa itong discussion. You have the dipole moment per volume. So this can be written as small p equals p. Instead of v, let's say you have d tau, d tau prime, let's say d tau prime. And I will substitute it here. Okay. So that the potential is uh, so it becomes an integral, then big P r prime over r squared theta prime. Okay. Now we will take a look at the right hand side. So if you take a look at the right hand side of the equation, like kani siya nga this equation here, so we can actually simplify this one by having this formula. Then take a look at this, kani, right? So recall that we have this. This is prime 1 over r. That is actually katuning sa previous pa natong discussion. I think sa first sem pa ni siya. Take a look at this sa inyong notes and add some reference ng mga books. So that is given by this relation. So we can substitute this. We can replace this one by this kaning uh, del. Okay. So we now have, so your potential now becomes this. We have the volume. So ako ibutang sa pikas ang P. Unahon ako suwat ang P. And then you have the dot product of this del prime 1 over r. And then this is theta prime. Okay, I hope clear as siya. So ma-follow ra. So if having that one, so we can simplify this kani siya. Kani nga, this is like a derivative raman siya. So we'll use this relation sa derivative. So use this relation. So we have del prime dot p um, over r. Okay. Then natin makuha ani nga nindot nga result. So 1 over r. If we take the derivative of this, it's like product rule. So una na akong derive ang p tapos i-constant na ko ang 1 over r. So I have prime dot p then plus i-derivative na po na ko ang 1 over r tapos constant ang p. So I have this dot del of 1 over r. Okay? So I hope clear na siya. So if we take a look at this, so kani siya, it's the same as this. Right? So we can substitute that one with this kani. So ang imuhang p dot ana is therefore del prime dot p over r minus 1 over r del dot p. So that, so substitute na nimo, we get this. Okay, duha na siya ka terms. So we have the volume del dot p over r d tau prime minus kaning second term, that would be volume gihapon 1 over r del prime, oh this is prime, okay, just use the prime dot p d tau prime. Okay, so from this we can actually simplify this one. We can simplify the first term. This one, nana siya identity. So if again, if we can recall or we can use the divergence theorem. So we discussed all this one already in our uh, previous semester, electromagnetism 1. So the divergence theorem has this relation. So if you have del dot f d tau, that's actually equivalent to integrating over a closed surface, okay, from volume to area. F dot dA. Okay, so this one, your first term, instead of integrating over a volume, will be translated into an integration over a surface area. Okay, so your volume, your potential becomes 1 over 4 pi epsilon naught. That would be closed integral as a surface area, as an area, 1 over r. So your f here takes the value of p over r. So this becomes p dot dA. Okay? This is dA prime. I hope you follow that. In the second term, you just have to copy that. Okay, that's it. So since so natin makuha ani nga relation gihapon. So this is potential, right? So if that is potential and that is over a surface area, and this one is potential over d tau prime. Diba the general formula of potential is like this? Okay, ako na lang isulat. The general formula of the potential is sa Coulomb's law, bita. If we have rho d tau prime, right, over r, and if it's an area, so if area, so this becomes ano lang. So if area ni siya, may mo na siyang sigma dA prime over r. I hope ma-recall ninyo. Then if it's a line, that's lambda dl prime over r. So, natin makuha ang correspondence ani. So, it seems like, since dA naman na siya, so this must contains a charge. Well, in fact, it actually contains a charge. Ang imong dipole, right? Dipole moment per unit volume na siya. So, this one, this P here in the first term that's integrated over dA prime, that's actually your charge, yeah, surface charge density. It corresponds to the surface charge density, and that is equal to P dot N, right? Because if you have this, if mo siya i-substitute diha, then you have sigma dA prime. So that is your potential. So the same is true with this. So kanisiya, that's actually B, raw B for bound. So bound charge na siya. Okay? So you have del prime dot, so actually mauna ang imong correspondence. So we can rewrite the potential as just this one. So 1 over 4 pi epsilon naught close integral over a surface. Then we have sigma over r dA prime plus, so it actually becomes a plus. We want a plus because we want to keep things simple. Okay, tanto siya minus diha para ma-plus siya. Okay, then we have v integrated over napatay pre-factor 1 over 4 pi epsilon naught integrated over a volume. We have bound charge rho sub b over r d tau prime. So that is your potential of the material of the dielectric. Okay, so it is easy to see from this equation that the potential of a polarized object, okay, is just the sum of two terms. Ang isa is potential produced by a surface charge, and the other is the potential produced by a volume charge. Okay? So, ang potential sa imuhang polarized material is actually composed of two contributing factors. One is that because of the charges lying on the surface, and the other one is katong charges nga naa sa sulod mismo sa volume sa imuhang polarized material. Okay. So from that, we'll take an example. So add page lang ta. So example, So find the electric field produced by a uniformly polarized sphere of radius r. So paggamit nato ang formula. So actually kanira man na siya ang formula. So we can find the electric field by knowing the potential. So magamit naman tayo nato tong formula nga electric field is just the negative gradient of potential, right? So we'll apply that later. Okay. So let me draw a circle para natay visualization sa to ang sphere. Okay. So the sphere looks like this and it has a radius r. Has a radius r and the direction of the surface, okay? Ang direction sa surface area niya is it's a vector quantity. It's always perpendicular or normal sa surface. And that is so if naa siya dinhi naapod din na ang imong direction sa normal nga vector. Okay? The n hat, direction of the surface. Okay, and the polarization is this way. Let's say diha ang direction sa polarization. And then say this is distance z and then naa siya angle diha nga let's say theta. Okay? So first is we need to find the potential both inside and outside. Okay? Duha man ni ka case ang kaning sphere. The potential niya, what's the potential inside and what's the potential outside. Now, in order for us to do that, actually, it's quite easy for us to do that because we already know a technique on how to do it that is discussed in the first lecture. I think sa first lecture ni siya sa kaninga sa ato ang course wherein this one will try to solve it using separation of variables in spherical coordinates. So nana dito sa nato pag-calculate. So before that, we'll be using this formula, kani. Okay. So ako na kaning kopyaon sa oh this one, then we have to copy. So kana right, and then we'll identify the sigma b first. Sigma b is katuman tong this one, you can recall. Tara, p dot n and ang rho sub b is negative gradient or divergence sa p. Okay. So this is p dot n. Now if you look at the graph sa to ang figure, this is the direction sa p and this is the direction sa n, so it makes an angle of theta. So that product of two vector in general is just p cosine theta and n is just a normal as a unit vector. So that's just the magnitude of this n hat is just 1. So you have p cosine theta and then the rho b is this. It's actually 0 because p, okay, it's the electric field produced we are trying to find the electric field produced by this is a uniformly polarized sphere, so uniform ang distribution sa p. So if you take the gradient of a uniform distribution, so it's like constant, so iyang direction it wala siya changes yung direction. So the gradient for that, or the dot product for that, it's not gradient. The dot product for that is 0. Okay, because this is uniform. That's uniform. So we are left with our potential as this. The A prime. Okay. So how do we solve this? This one? So na method, pwede mo siya i-directly integrate, but it's more difficult than using a separation variable. Masayon man ni siya nga method. Masayon siya buhaton. So use separation of variables to solve this. Okay? So use a separation of variables. So I hope maka-recall mo sa katong separation of variables na to nga itong gibuhat. So we'll do it in this example. So we have this. Right? So R theta lang imong potential. So wala kay phi dependence because nasa symmetry along the phi. So anywhere you look sa under phi rotation or phi na rotation, it looks the same in potential. So there must be no dependence on the phi because of azimuthal symmetry. And the formula for this, if you can recall, so recall lang sa inyong mga notes. So na-solve naman ni siya, we'll just have to use this formula. Right? So this is for the potential R less than R. So that's inside. And for the potential outside, so this is BL over R to the L plus 1, PL. So this is outside. So next thing to do is we have to determine the constants AL and BL. And in order for us to do that, we'll use the boundary conditions. So the first boundary condition is this. So use the condition. Okay. So use the condition that the potential is continuous at R is equal to R. So sa iyang radius. So ato na siya i-equate nindo ha. Right? So ang potential is continuous at R equals R. So doing that, we have this. Oh, at R equals at R equals big R. So this becomes big RL PL cosine theta. So the left hand side is katong kani R less than R, and the right hand side of the equation is katong R greater than R. So I hope naka-follow na mo. Please ask questions sa atong group chat, or you can email me, or you can contact me anytime if you have questions. Okay, that's it. I hope na follow ra siya nga process. Sa left hand side, we have this one, R less than R. For the right hand side, that's R greater than R. So we'll equate this one. So we'll have to, so madrop na nato ang summation. So ang mabili na lang is this. Right? So muna na siya mabilin. And then pwede na to kuhaon ng A sub L in terms of B sub L, or for this case, we'll just have to get B sub L in terms of A sub L. Right? So 2L plus 1. So cross multiply lang na siya. After that, we'll use another boundary condition. Then use the fact that okay. So it's like ang imong electric field is discontinuous at R equals R. This katong kaning unang condition is the potential itself. Okay, the potential itself is continuous at R equals R. So at R equals R for the electric field, or the derivative of potential with respect to R, okay, so the gradient niya of the potential with respect to R only, so it's actually discontinuous given by this amount. So potential na to ang formula outside, R less than R, R greater than R. This is potential inside, R less than R with respect to R. Then evaluate na nimo at R equals big R. So that's actually discontinuous with this amount. So the surface charge is your sigma, right? So that you have to perform the derivative. So kaning V out is this. You take the derivative of that with respect to R. And this one also take the derivative with respect to R. And also, BL is given by this, A sub L. So wala na tayo BL, it's just in terms of A sub L. So we'll consider deriving this one sa outside. Una to ang outside. So outside is given by this. Okay, so taking the derivative with respect to R, so you will just have to follow the rules sa pagkuha sa derivative. So we have ito, PL cosine theta. So if we take the derivative of this one, so pwede mo na ako ni siya isaka, right? Like BL um, R to the L plus 1. Right? It said na nasa ubos, ako siyang gisaka. Okay? And then, if you take the derivative of that, manaog man siya, so na ako'y negative L plus 1 diha. And ang imuhang numerator, exponent, you have negative L, plus 1 minus 1, so actually it becomes negative L plus 2. Right? That becomes L plus 2. So evaluate na siya from kana. So if evaluate mo ang small r to big R, so ato na lang i-replace ang small r with a big R. So in this case, inaog na nako siya. So actually that becomes BL over R L plus 2. So the same thing happens sa katong inside, this one sa inside. Okay? Ako na lang na siya ibutang diretso ang result. Then it's for you to find out and check if sakto ba di siya nga pagka-derive. So we have L plus 2. Oh, okay, sorry. We have L, A sub L, R to the L minus 1, PL of cosine theta. And this is actually equal to this one. We have negative sigma b of theta over epsilon r. Okay? So I hope na follow ra. And then we'll express BL. Okay, i-express nato tanan in terms of AL, I mean, kaganina. So ang BL, himuon mo og AL r to the 2L plus 1. So that becomes, kung isulod ang L, kay count man ni siya sa summation. So BL becomes AL r to the 2L plus 1 over r to the L plus 2. Then just copy the PL cosine theta minus this. So copy lang niya. Okay, dali naman siya, di ba? Ang kaning kuan. Just have to follow the math lang yun, ang iyang algebra. This one. Next is, we can still further simplify. So simplify, pag-give ni siya. We have L plus 1. Ang r to the 2L plus 1 o r to the r over L plus 2, mausa ni mo na siya as r to the L minus 1. PL cosine theta. Copy everything here. Okay. So, we can simplify this. Kani siyang last term. Ato nga simplify because na may common ani. Right? Ang common nila is this. So, take a look at this. Oh. Okay. Na. Ang common nila is this. This one. Right? Parehas sila. Except sa kaning for this case, wala na siya L dere. Ah, ana la. Ana lang. So AL r to the L minus 1 PL cosine theta at theta. So ato na siya i-combine ang similar terms. That will just give us this. Okay? So, muna siya ang common niya is kani AL r to the L minus 1 PL cosine theta. Right? And then, we have L plus 1 here, L plus 1 plus L, right? Dini, kay L mana. Or all in all, that's 2L plus 1, right? We're going to simplify. We have 2L plus 1. So this is, so ang negative, mawala siya. So, palin sa pikas, ma-positive na po din siya. That becomes positive sigma b of theta over epsilon naught. Okay? So, I hope na follow ra. So, we can substitute now the value of sigma b. So, going back sa katong problem na to, what's sigma b? Tara. atong sigma b na to. Our sigma b is tara. So if you look at this, ato nang kopyaon. Uh, uy, ano man ang prime. So difficult. Well, anyway, so kana siya. So recall, okay. So this is your sigma b, right? Sigma b is p cosine theta. So ato na siya i-substitute. So that means you have this. Okay, p cosine theta epsilon naught. Okay, if you take a look at this, so if the attached correspondence, right, this is summation of all L from 0 to infinity, okay, then you have your constants and so on. The right hand side is, if you take a look at this, right, cosine theta is just P1, right, and L is just 1. So there's no other way ma-satisfy ng left hand side if L equals 1. Okay? If not equal to 1, so wala, 0 siya. So this can only be satisfied, the left hand side equation with the right hand side, if L is only, if L is equal to just 1. So therefore L is equal to 1. So mawala ang imong summation, it will be replaced with just, substituted with just 1L. So this becomes 3A1 R to the 0. Okay, 1 is just 1, so R na siya. And then P1 cosine theta, right? P1 cosine theta is just cosine theta. That's equal to P cosine theta over epsilon naught. So easily we can get A1 as P over 3 epsilon naught. So that's our A1. How about our B1? Okay, ang B1 nato is ito ang relation. So B1 is just A1 times R to the 3. Okay. So A1 is just, B1 is just A1 times R cubed. Or, substitute mo ang value sa A1, that becomes P over 3 epsilon naught R cubed. So that's your A1 and your B1. So you are now in a position to get the potential sa inside and sa outside. Okay? So recall, so you can get the potential. So ang potential nimo is kanila man siya nga formula, right? If mabalik ka ani, o ato. Tura na siya nga formula, kani. Right? Where the summation vanishes is just L equals 1. So A1 R to the 1 times P1 cosine theta, where A1 is just this, kani. Tala. So we have A1 R to the 1 or just R, P1 cosine theta. So therefore, the potential inside is just P over 3 epsilon naught R cosine theta. Right? I hope na follow ra. Okay? So this is for r less than r, and for outside is gonna b1 over r square times p1. Okay, so b1 over r squared times p1 cosine theta, where b1 is just p over 3 epsilon naught, p over 3 epsilon naught, and then na ko'y r cube, sa ubos na pud ko'y r square, and na ko'y cosine theta. This is r greater than r. So we have successfully determined or calculated the potential of a polarized material. Okay, so polarized material because it's given by this, right? P. So now we can calculate the electric field because ang gipangutan naman is ang usa kay electric field sa material, sa polarized material. So that would be easy by just looking at this formula. So if let's take a look, let's consider sa inside. So for r less than r, okay, the potential is given by this p3 epsilon naught r cosine theta. So take note that this one that can be rewritten as z, okay, uh, in your cylindrical coordinates. Z is just right. If you look back here, this is z. So z is just r cosine theta, right? Or just this, it's like this one, z r cosine theta. So v is just p over 3 epsilon naught z. Okay, and then we can calculate the electric field. It's just the negative gradient of the potential, and that is found to be negative p over 3 epsilon naught. That's it. With respect to z, okay, then that's z hat. So the electric field inside is given by this formula. So ang direction is a z hat. So straight lang siya, straight line. Kasulod sa sphere. Okay? However, the case outside is different. For r greater than r, we have this formula here. Okay? So we can calculate. Okay. Okay, ato ibalik ang atong potential. We have p over 3 epsilon naught r cube over r square cosine theta. So that can be rewritten as this. Ato siyang i-combine ang kaning mga terms. R cube over 3 epsilon naught r square. We have p cosine theta. And p cosine theta is just this. Mo siyang i-dot product. P dot r. Right? I hope it makes sense. This is a dot product. And this is unit vector r. And if you take the dot product of that, you get p cosine theta. So that's the same. And then we can do this r cube over 3 epsilon naught square. And then ato ano siyang kaning capital P is just P. Capital P is just, okay, we write this, where capital P is just small p over volume, right? Or the volume is just the volume of the sphere, 4 pi r cube over 3. Okay, so ito na substitute din here. That would be So mahimo siyang small p dot r hat over the volume, which is 4 pi r cube over 3. So pwede siya ma-transfer sa taas, over 3. And then mag-cancel ang 3 and of course ang r cube. You are just left with this. Right? Or this is just 1 over 4 pi epsilon naught p cosine theta over r squared. Actually, na-calculate na nato na siya before. You take a look sa inyohang previous discussion we're in. This is actually this is exactly the potential of a dipole. It's a single dipole physical. Potential of a single dipole. Di ba naka-calculate na tayo before? You try to review the notes and the video if wala mo if nakalimot na mo. You try to review the video. This is actually the formula of a potential of a single dipole, and we already calculated the electric field for that. And di ba ang dipole is ang electric field is like ingon ani yung electric field. Right? If maka-recall mo sa electric field sa dipole. So this is the potential or the electric field niya nga form sa outside sa sphere. Right? This is outside and this is inside. So if we combine those potential electric field mga terms, so let me draw a circle. Diba, originally this is our sphere of polarized material, and then we calculated the electric field at the potential inside and outside, and from the potential we can know the electric field. Okay, so we can actually draw the electric field. This is inside the electric field, and the direction is in the z direction, and it's negative. Negatives paubos siya. So linear lang na siya ang sasulod. Sinana ang iyahang direction sa electric field, straight line, and it's negative, right? While outside, it's governed by this potential. And if you go back sa katong previous discussion, ato nang na-calculate actually ang electric field ani nga terms, that's in terms of r and theta, okay? R and theta dependence. So it's like this. So outside, it resembles that of a dipole, like that. Ang iyahang electric field. So ano ang direction? Okay, so if you have a sphere, a polarized sphere, and nakalculate mo na to ang yang potential and also the electric field because of the potential, the electric field pattern is given by this. Okay, so that's how the electric field looks like in looks like of a sphere na polarized material. Okay, this is the electric field. It's governed by this equation. For the sa sulod niya inside of the sphere, it's given by this electric field. So straight line lang siya along the z direction, while for the electric field outside, it's dependent on r and theta. That's why mo curve na siya diha. Okay, so that ends ato ang discussion for this kanilang nga discussion, and next video will continue with our discussion on dielectrics gihapon, and then we'll be applying Gauss's law in the presence of dielectrics. Okay, things will be much complicated, but it's doable gihapon. Okay, so that's it. See you on the next video and stay safe.